This is our little problem. Calculate the diameter of a solid cylinder which has a height of 0.82 meters and a total surface area of 2 meters squared. So thinking about the surface area, so the surface area is composed of three parts. You have the area for the top, an area for the bottom of the cylinder, and you have the area for around the sides. So looking at the shape, area for the top, shape is a circle, therefore the formula for that will be pi r squared. Similarly for the bottom of the cylinder, the area again will be pi r squared. The area for around the sides, whenever you split it out, if you imagine you unravel it, it'll form a rectangle which will have height h, but the distance along the top will be the circumference of the circle, which will be 2 pi r. So the formula for the area around the sides will be 2 pi r h. Putting these into the equation for surface area, for the total surface area, we get pi r squared plus another pi r squared plus 2 pi r h. Now what we can do is simplify down the formula. So we have 2 pi r squared plus 2 pi r, and we can do our substitution because we know the height of the cylinder, which is 0.82 meters. The total surface area, we're told in the question, takes a value of 2. We're going to try to rearrange this equation, tidy it up to get a quadratic. So we have 2 pi r squared plus 1.64 pi r minus 2 equals 0. So now this kind of takes the shape of a quadratic. What we can try and do is cancel pi or divide this equation by pi to make it a little bit simpler. So 2 r squared plus 1.64 r minus 2.0 divided by pi equals 0. And if we try and make it a little bit simpler as well, we're going to take our equation and divide it by 2. So you're just left with r squared plus 0.82r minus 1 over pi equals 0, or just put it down in numerical terms, r squared plus 0.82r minus 0.3183 equals 0. Now that's the equation here is in the form of a quadratic. We can identify the values for a, b and c, and you then use the quadratic formula to solve for a solution for the value of r in this case. So we compare our equation against the general equation for any quadratic, ax squared plus bx plus c. A is a value in front of the square term, b takes a value of 0.82, c takes a value of minus 0.3183. So the value for a is going to be 1. And we'll substitute our values into our quadratic equation. Remember, our quadratic equation is minus b plus or minus square root of b squared minus 4ac all over 2a. Put our values in, minus 0.82 plus or minus b squared, so 0.82, square that, minus 4 times 1 times minus 0.3183. I'm going to take a square root of all of that and divide that by 2a, 2 times 1. We'll tidy this up. 0.82 plus and minus 0.6724. Carve out the two minus signs, making it plus 1.2732. Take a square root of that. All divide that by value of 2 minus 0.82 plus and minus the square root of 1.9456, all divided by 2. So I'm going to separate out and get our two possible solutions. One when you use the plus sign between the two terms on the top line. One when you use the minus sign. You can put it into your calculator and you can work it out. So our two answers we get are 0.2874 meters, or x equals minus 1.107 meters. In this case, we kind of have to ignore the negative answer. Although numerically correct, it doesn't really make any sense. So therefore our viable solution is going to be a value of 0.2874 meters, or because you're asked in the question to work out the diameter will be twice the radius, and hence multiplying the radius value by 2, 5748 meters. And that'd be your answer.